Okay. So we've done everything the hard way with regular JavaScript, which was good. Let's learn how to do stuff in React. I am recording. Allegedly. We'll find out. All right. So, does everybody know where React came from? Who made it? Facebook, yeah. So a lot of Facebook's website, pretty much all of Instagram's front end is built in React. And then they open sourced it so everybody else could use it. So that's nice of them. Somebody that can read that from where you are, who would like to read that? Anyone? I'll pick somebody. I will. Clayton.
What is React? A declarative, efficient, and flexible JavaScript library for building user interfaces. It encourages the creation of reusable UI components which present data that changes over time.
Thank you. That was beautiful. All right. So this definition is one that I kind of pieced together from multiple sources. There's a couple different pages that Facebook made, as well as some blog posts and stuff that I've read. So kind of pieced together all the explanations that made the most sense to me. But there's probably some words in here that I'm sure you know what the words are, but you don't necessarily know what they mean in this context. So let's talk about the first conveniently italicized one, which is declarative. Does anybody know what, in this context, the opposite of declarative would be? Close. Declarative versus imperative. Now that you've heard both, do you have any idea what the difference would be? No. All right, so declarative is like, well, let's start with imperative. So imperative is like describe how to do something, whereas declarative would be more describing what you want to do. So it's a bit more abstract. That still probably doesn't necessarily make a lot of sense until we talk about some examples, so let's do that. Example number 1, arriving at a restaurant. Who wants to be my host at the restaurant? Matthew? You shook your head no, which means yes. What's your favorite restaurant, Matt? Moe's? All right. You be the host and welcome me to Moe's. I'm not going to make you do the really excited version. So, hi, Matt. I'm here with my friend Davey. So there's 2 of us. We're going to need a table for 2. So I'd like you to take me over to that table over there. And then, I don't think does Moe's even have menus, but if you could bring me menus, that would be great. Also, probably some silverware in the nice little napkin would be awesome. And then if you could have somebody else come over to take my order, that would be cool. And then I'm going to give them my order. Then they'll take it back to the people in the kitchen. And then they'll make the food that I ordered. And then if somebody could bring it out to me, and then I'll eat it. And then I'm going to throw away my trash and leave. Is that cool? Awesome. So you think that was more how to do something or what to do? More how to do something. That was more of an imperative thing, because I literally told you every single step of what's going to happen, right? So let's try this again. Declarative way. Hi. I'd like a table for 2, please. And scene. So you kind of see the difference. It's more the declarative way is like, I would like to eat here. I have 2 people, right? And then we kind of assume that what needs to get taken care of is going to get taken care of, as opposed to the imperative way where I kind of come across as a jerk and condescending. Not that you can't be imperative and not condescending, but. Example number 2, driving a car. Does anyone in here know how to drive a manual transmission? Oh, more than last time. There were only 2 people in the last one that knew how to do that. But yeah, I learned to drive on a manual, and that was exciting. So another good example of declarative versus imperative would be driving a manual transmission versus an automatic transmission. So you think about it, if you have to drive a stick shift, it's like, okay, I get in the car, I push down the clutch, turn the key to turn it on, put it in first gear, slowly start letting off the clutch while I'm adding gas, And then once I get up to a certain RPM, then I have to let off the gas and put in the clutch again, shift to a different gear, let it back out. Versus driving an automatic, I turn the car on, I put it in drive, and I push the go pedal, right? So it's a bit easier. So you feel like you got a little better handle on declarative versus imperative now? Okay. So let's look at some code examples. So this function, take a second to look it over. And once you have looked it over, would you say this one's more imperative or declarative? Imperative? I heard an imperative. And why would you say that? Because it's what we've been doing.
It feels like punishment.
Yeah, so this is the imperative way. Because I'm saying, okay, first I'm going to initialize an empty array and assign it to the variable multiplied array. And then I'm going to initialize a counter. I'm going to count until we reach the original array length. And I'm going to increment that counter every time of the for loop. And then inside there, I'm going to set another variable, set it to the original array value at that index, multiply by 3, push that onto the array that I declared, and then return that. Is there another function that we know that would do the same thing in a much more declarative way? We've used it a few times at this point. Map, yeah. So that same function can be original array.map number times 3. So basically, just I'm declaring what I want to happen. I'm saying just go over this array and multiply everything by 3 and give me that, as opposed to all those individual steps. So now that we understand declarative versus imperative, next italicized word, efficient. Why is it efficient? So the first thing to understand is that DOM manipulation is slow. So anytime you are actually changing the HTML markup on a page, that is relatively slow compared to manipulating things in JavaScript. So the reason why React is so efficient, especially when you get into more complex apps where there's a lot of things changing all at one time, it maintains what we call the virtual DOM. So every single piece of the UI in a React app is first represented as a JavaScript object. So React is keeping track of everything as JavaScript objects. And so what that allows you to do is as things change in your app through user interaction or through new data coming in from API calls, it allows it to compare the current state of things in its current representation of all these JavaScript objects to what things will be after that change occurs. And so that way, it can see specifically, like, okay, if this particular thing is changed, then I have to change this part of the UI. I don't need to re-render everything. I can just make this one tiny change, and so that keeps everything fast, because I can compare JavaScript objects and then only change the specific parts that I need to. So the process of determining what has changed is called diffing, and then the process of making those changes is reconciliation. Make sense? More or less? All right, so how do we actually make an app in React? So there's 4 things we need. Number 1, I need some HTML page with at least one empty element. So, I mean, really, it could be pretty much anything. Usually, it's just like a div with nothing in it, and usually with an ID on it, just so it's easy to locate on the page. And basically, well, we'll get to that in point 4. Number 2, we need the React library. So if we're going to make React, we kind of need to have a reference to the library. 1 or more React components, which we will soon see how to make. And then finally, a JavaScript call to attach the React component to the empty HTML from step 1. So basically, we're finding that empty div on the page through a JavaScript call and saying, hey, take this div, and inside that, where it's currently empty, we're just going to render everything for our app. All right, so moving on to components. So think about some websites that you use regularly. This morning we gave the example of Reddit. Everybody familiar with Reddit? So when you think about components, this is one of the most important things to become familiar with to be successful with React. think of a component as a particular chunk of the user interface. So like a piece of it that has a specific function. So when you're thinking about the Reddit page, what are some things that are on that page? A thread, sure. What else? Subreddits, yes. Specifically, let's just think about the main page. So we might have links to other subreddits, right? What else? Ads, yeah. So ads. Anything else? Yeah, top banner. The search, even though it's terrible, yeah. Signing in and out, yeah. So as you're thinking about these things, each of those kind of do very distinct things, and they also have their own unique look to them, right? So each of those are great candidates for breaking out into an individual component. And that's part of where the reusability comes in as well. So especially when you think about things like navigation links, I mean, those might show up on practically, or like the header, those might show up on practically every page. So having them as components allows them to be duplicated. So take this as an example. So if this is like some basic HTML, like a header, this is for an excellent site that I made, which is clearly the best because it says that right in the H1 at the top. And then we have a customized H2 below that, where I'm welcoming Steve to my site. And then we got 4 different nav links. So that's cool. So like I said, this is probably something that would appear, regardless of how many pages my website has, it would probably appear at the top of every page. So I would either have to copy paste this into each different HTML file for that, or wouldn't it be cool if I could just make my own element, call it app header, give it the name that I wanted rendered, and then it would just do all that for me wherever I put this tag in. That would be cool, right? That's totally how it works. So this is a pretty basic React component. So we saw classes last week. So every React component is a class. So we've not talked about extends yet, right? So we're declaring a class called app header, and we're saying that extends React component. Has anybody used a language that maybe uses the extends? Yeah. What does that mean? Java, yeah. And what's that mean in Java?
It's like a parent class.
Yeah, exactly. So it basically means our class is going to inherit from React component, right? So it's going to automatically get all the methods and properties that a React component would have, and then we can add our own methods on top of that. So the one function that, or one method that every React component has to have is this render method. And basically all that does is it returns us a chunk of stuff to render. So basically we took the markup, and you can see it's almost exactly the same as it was here, right? With a couple subtle differences. Can anybody see what the differences are? Yeah. Yep. So in that H2, you can see I've got curly braces, and inside that, this.props.name. So we'll get a little more into props later. But basically, anywhere where you see the curly braces, that's telling React, hey, inside this part, evaluate JavaScript. So you can put any sort of valid JavaScript expression in there. There's one other thing that's a little harder to see. Anybody see what it is that's different from normal HTML? I'll give you a hint. It's on the UL. Yep. So it's class name instead of class. Why couldn't we just say class there? Yeah.
Because class is a keyword that makes a new class in JavaScript.
Exactly. So even though this looks like HTML, it's not. We're inside a JavaScript file, right? And class actually means something to JavaScript. It's up at the top of our file here, right? So if I say class, it's going to expect to actually like start a new class. So you have to say class name, so that way React knows, okay, this becomes a class in the markup, but I can't say class because we're inside a JavaScript file. So what this is called, even though it looks like HTML, it's not. This is JSX, JavaScript XML. So it's just a way that allows us to write stuff that looks very similar to what the final markup will be, but also interpolate JavaScript wherever we need to. And basically a lot easier than what you're going to see on the next slide. So it's possible to write React components purely in JavaScript and not use JSX, but then you end up with something like this. So essentially what all that JSX compiles down to is calls to react.create element, and then you pass it the name of the element as a string, the arguments to it, the actual child properties to it, and they just get nested further and further down. So you can see you definitely can do it that way. I wouldn't recommend it because it's not fun to write it that way. But yeah, just understand the difference between that JSX looks like HTML, but it's not actually HTML. Let's talk a little bit more about the props. Who wants to read this one? Sam?
Component props. Conceptually, a React component can be thought of as a JavaScript function. They accept arbitrary inputs called props and return React elements describing what should appear on the screen.
Thank you. That was good emotion on that one. I liked it. All right, so that's a good way to think about it. You can think about your React components, really, they are just kind of functions. So you can put arguments into them. Those arguments are called props. And then that render method is basically your return value for that whole component. That's what it returns, and that's what eventually gets rendered to the screen. So just like arguments to JavaScript functions, they can really be pretty much anything. So they could be strings, numbers, functions, other objects, booleans, arrays, symbols. Here's a few examples of the kind of things you can put in. So you can define an alert me function. So this is where you would actually be calling your component in the markup. You can pass that alert me function as a prop called alert me, a boolean true as the prop my fave, and then a name, and that's just a string. So then you can see in the actual render method, so like that button has an on click where it's going to call that alert me function that we passed in. So it's just going to be prefixed with this.props because that's the object it's going to attach it to. And then the next paragraph is going to say what? My name is... What's this.props that name? Emilio. And then my favorite boolean is... Yeah, true. So you can pass those things in. Now one thing I do want to point out here is what's different about the name prop versus the other two? It's not a trick question. There's something very obviously different about it. It's a string instead of what? Like there's no what. Yeah, I see this motion. There's no curly braces, right? So you could put the curly braces around this and it would work fine. Just know that strings in particular are ones that you don't have to put it around. So it's perfectly fine to do that, but for strings in particular, they're not required. Go away, stupid thing. So I remember when I was first starting to learn React, I was like, I don't understand why sometimes you have the curly braces and sometimes you don't, but that's the difference. So the important thing to understand about props is they are received from outside the component, so it's something that gets passed in, and then it cannot be changed by the component itself, so they're immutable. There's also the concept of state. So since I can't change props, what do I do if I need to actually like keep track of something and update the state of things? So there's also state. So like in Mega Roster, we have our students array, right? So that would be an example of what would be similar to React state. You could consider that an example of state. So I have to be able to modify it because otherwise I have no way of keeping track of when we add something or edit it. So if a component needs to keep track of its own data and also be able to modify that data, then we use state. It's initialized in the class constructor, and you have to use the set state method when you want to change it. So here's my lovely clicky counter component. So again, we're extending the React.component. And then in my constructor, we're setting this .state. So this .state exists, but we're going to initialize it to an object where we have a property of count, and that's initially set to 0. And then we get an update count method. And what is that going to do every time that's called? If I call it once, what's state.count going to be? Right. So every time I call that, it's just going to add 1 to it. And again, we're not just saying this .state equals something. We call this .set state to reset the state. The reason you have to use this .set state instead of manipulating state directly is that part of, again, kind of going back to React's efficiency of knowing what to re-render, if you just manipulate state directly, that kind of goes around that process, so it doesn't know to re-render properly. So using set state kind of goes through all the proper channels, so it updates everything correctly. And then in our actual component that gets rendered to the screen, we have a button where on click we're going to call that, and then a paragraph that just basically outputs, tells us how many times it's been counted. So every time I click that button, it's going to call the update count method. It's going to add 1 to the current state.count, and then that'll get updated automatically in the view for us. So last but not least, how do we get it attached to the DOM? So these are not all actually in the same file. I just put them all on one slide for clarity, for compactness. But say we have an HTML file where we have that div, empty div with an ID of root. We have a basic component that just returns a div that says React app. And then this is the part that actually connects the two together. You call React DOM.render. You tell it what component to render, and then what thing in the DOM to attach it to. So we just do a normal document.getElement by ID, root, and then it will basically take that div with the ID of root and put the markup for our component inside that. Make sense? Cool. You ready to actually build something? Hooray! All right. Davey's going to walk you through. Yeah, you.